Lesson number 4. Angles and pair of angles. The interior and exterior of an angle. In the plane of the figure alongside, the group of points like point N, point M, point T, which are not on the arms of the angle, form the interior of the angle PQR. The group of points in the plane of the angle, like point G, point D, point E, which are neither on the arms of the angle nor in its interior, form the exterior of the angle. Adjacent angles. Look at the angles in the figure alongside. The ray MQ is a common arm of the angles angle BMQ and angle QMT, while M is the common vertex. The interiors of these angles do not have a single common point. They may be said to be neighboring angles. Such angles are called adjacent angles. Adjacent angles have one common arm and the other arms lie on the opposite side of the common arm. They have a common vertex. Adjacent angles have separate interiors. In the given figure, MB is the common arm of the angle BMT and angle BMQ. However, they are not adjacent angles because they do not have separate interiors. Two angles which have a common vertex, a common arm, and separate interiors are said to be adjacent angles. Observe the figure and complete the table for angle AWB. Points in the interior are N, C, Q. Points in the exterior T, U, Q, V. Points on the arms of the angles G, B. Complementary angles. If the sum of the measures of two angles is 90 degrees, they are known as complementary angles. Let's learn. Draw angle PQR, a right angle. Take any point S in its interior. Draw ray QS. Add the measures of the angles, angle PQS and angle SQR. What will be the sum of the measures? Equal to 90. Here, angle PQS and angle SQR are mutually complementary angles. Example. Observe the angles in the figure and enter the proper number in the box. Measure of angle ABC is equal to 40 degrees. Measure of angle PQR is equal to 50 degrees. Measure of angle ABC plus measure of angle PQR is equal to 90 degrees. The sum of the measures of angle ABC and angle PQR is 90 degrees. Therefore, they are complementary. Supplementary angles. A line AC is shown in the figure alongside. A ray BD stands on it. How many angles are formed here? Measure of angle ABD is equal to 120 degrees. Measure of angle DBC is equal to 60 degrees. Measure of angle ABD plus measure of angle DBC is equal to 180 degrees. If the sum of the measures of two angles is 180 degrees, they are known as supplementary angles. Here, angle ABD and angle DBC are supplementary angles. Opposite rays. Two rays which have a common origin and form a straight line are said to be opposite rays. In figure 1, ray BC and ray BA meet to form an obtuse angle, while in the figure 2, ray BC and ray BA meet to form a straight line and we get a straight line. Here, ray BC and ray BA are opposite ray. In the given figure, LP and PM are opposite rays. NP and PT are opposite rays. Ray PM and PT are not opposite rays. Angles in a linear pair. Angles which have a common arm and whose other arms form a straight line are said to be angles in a linear pair. angles in a linear pair are supplementary angles. The angles PQR and angles RQS in the figure above are adjacent angles and are also supplementary angles. The arms that are not common to both angles form a pair of opposite rays. That is, these arms form a straight line. We say that these angles form a linear pair. The sum of the measure of the angles in a linear pair is 180 degrees. Measure of angle PQR is equal to 120 degrees. Measure of angle RQS is equal to 60 degrees. Measure of angle PQR plus measure of angle RQS is equal to 180 degrees. Vertically opposite angles. The angle formed by the opposite rays of the arms of an angle is said to be its opposite angle. In the figure alongside, line PT and line RS intersect each other at point Q. Thus, four angles are formed. Angle PQR is formed by rays QP and QR. The rays opposite to ray QP and QR are QT and QS respectively. These opposite rays form the angle SQT. Hence, angle SQT is called the opposite angle of angle PQR. The property of vertically opposite angles. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles.